All right, well, welcome. This is, as you can see, lesson 5.3, and it is adding and subtracting fractions and actually mixed numbers as well. And I put revisited because this is a skill that we did in course 1, if you were with me last year. But we are going to do a lot more with it, and we're going to do it really quickly. So, put your seatbelt on, and let's get started. All right, first let's talk about what happens if we have like denominators. So I'm going to write down a couple examples here, and let's go through these quickly. All right, so the top one is pretty straightforward. We already have a common denominator of 11, so I don't have to do anything there. So I just add the tops. 3 plus 7 is equal to 10. Okay, be careful you don't do anything to the bottom. You get a common denominator, and the denominator stays the same. Because remember what the denominator means. The denominator is basically telling you the size of pieces. So what we have done is we have taken a whole something, maybe a pumpkin pie, and we've divided it into 11ths. And so what this problem is really saying is suppose you take 3 of something plus 7 of something, what do you end up with? You end up with 10 of something, and my guest is just joining me. So the bottom is really describing what it is we're dealing with. So we're dealing with 11ths. Something divided into 11ths. Okay, so that's the first one. The second one, would you like to join in? So Max is joining me for this video. Max, what should I do on the next one? Check the denominators, and what do you see?
12 and 12.
They're both the same.
It will be 12.
So it's going to be, we're going to be dealing with 12ths. So let's go ahead and put the denominator down. It doesn't ever change. And what do I do on top?
You add.
Yep. So I get 9 plus 5 is
14.
And that's a little bit of a problem. Why?
Because the what's it called, is bigger than the denominator.
Yeah, it's top heavy. So we've got a numerator that is bigger than the denominator, so we need to change this into a mixed number, right? So 12 goes into 14. Once with a remainder of?
2.
And we get 1 and 2/12, but there's still an issue. That can be reduced, can it?
Yes.
So take a 2 out, what do you get?
1 over 6.
1 and 1 over 6. Be careful when you reduce it that you don't just get the 1 over 6 like Max said, but always write the whole number down first. Okay, so that's that one. All right, so that's what we do. Now, what about if the denominator happens to have a variable in it? Well, the rule is exactly the same. Now, you probably can't draw a picture of what it means to divide up a chocolate bar into 3x pieces. If we knew what x was, you could. If x was 2, we're dividing it up into sixths. But that doesn't matter. These denominators are both the same. So the rule is, if we have a common denominator, just keep it the same, right?
Yep.
Even if it has a variable in it. And the top is just 7 minus 4, which is?
3.
3. And while I still don't know what x is, I do know that anything that has 3 on the top and 3 times something on the bottom, both the top and bottom are divisible by 3. So take it out, and we get 1 on the top, and we get x on the bottom. What I basically did here, here's how I show my work. I divided by 3 on the top, so I divide by 3 on the bottom, and I get 1 over x. And that's my final answer. All right, so that's a quick review. Well, it's not all review. So that's what we do when we have like denominators. And this part right here with the variables is something that you haven't done before. Okay, so that's something to be on the lookout for. All right, now let's talk about what happens when you have unlike denominators. All right, now we've already talked about this a little bit. There's a couple different ways to deal with getting a common denominator. Okay, the whole reason that we reviewed least common multiple is because we talked about in 5.1 and 5.2 that the least common multiple of the two denominators is equal to the lowest common denominator. Okay, it's basically the same thing. So we also have run into the rule of 4. And the rule of 4 is a little more of a brute force method where we're just going to multiply the bottoms together. All right, so the first one, honestly, if we do the lowest common denominator method, what is the lowest common denominator of 3 and 5?
15.
15. So we're going to have to multiply them together anyway. So let me show you rule of 4 first. Okay, so rule of 4 is called the rule of 4 because it has 4 steps. The first step is you multiply the two denominators together. So 3 times 5 is 15. Okay? The second step, we'll switch colors here. The second step is you do the crisscross method like we do when we're comparing fractions, and you do 5 times 2 is 10, and 3 times 1 is 3. Okay? And then you go ahead and you perform the operation that was in the middle. Now, I think that was a minus. I kind of wrote over top of it.
Minus.
Yeah. So 10 minus 3 is 7, and we get 7 over 15, and that can't be simplified, so that's our final answer. Okay? Now, what we really just did, had we done it with common denominators, we would have done we would have done the exact same math. We would have wrote the first fraction as something over 15, and we would have said, okay, 3 goes into 15 5 times, so 2 times 5 is 10, so that first fraction, 2/3, is the same as 10/15. Similarly, the second fraction was over 5, so we're going to multiply it by 3 to get 15, so we're going to say minus 3/15, and we subtract and we get 7/15. So really, rule of 4 is just a shortcut of doing the same trick. Okay. Now, there's times where rule of 4, if the denominators were a little bit bigger, is going to make things a lot harder. And this one is a little bit of an example of that. This is not too bad, but 8 and 4, what would the common denominator be here? What do they both go into?
They both go into 8.
Yeah, 8. In which case I don't have to do anything with the front fraction, and it's already negative 7/8. And the second fraction, look, all I do to make it 8 is double it, right?
Yep.
So 4 doubles and becomes 8, so 3 doubles and becomes 6. All right, now I'm adding these. Now, here's something else that we can do. Now that we've got integers and we've dealt with positive and negative numbers, we can throw that in the mix while we're doing this. So this is a negative 7/8 plus 6/8. Well, all right, so it's the plain old regular 3 commandments. We're finding a positive and a negative. They're different signs, so the difference of 7 and 6 is 1, except we're dealing with eighths, so it's 1/8, and the negative was bigger, so this is going to equal negative 1/8. So that's kind of cool. That's a combination of using LCMs, or least common denominator, lowest common denominator. It's the fraction stuff we reviewed last year, and it's also throwing in positive and negative numbers. Okay. This last one, let's add one more element to it. Let's add variables. So what would the common denominator be if your denominators are 7 and m? And again, we don't know what m is.
7m.
So you're going to have to do this kind of the rule of 4 way. So multiply the two denominators together, you get 7m. Okay? And so how many times does 7 go into 7m? Goes in m times, so this one's going to become 3m, correct?
Yes.
And m is going to go in there 7 times, so this one's going to become 14. Again, we're subtracting, but I don't know what m is, so I'm going to have to leave it as 3m minus 14. Those are not like terms, so I have to stop right there, and I'm done. I also can't cancel, because even though there's an m in the 3m and the 7m, there's no m in the 14. So that is the final answer. So that's combining variables, unlike denominators, finding common denominators, and doing all the like. So that's what we're pushing for. And we will practice this in class. All right, last thing, mixed numbers. Basically same old, right? The only deal with mixed numbers is don't forget that you have the whole numbers around. And I would strongly recommend that you do that part first, because that's the part we tend to forget. So 3 plus 1, the whole numbers, give me 4 whole numbers, and then 3/5 plus 4/5 is 7/5 clearly, and again we've got that top heavy fraction.
So 5.
Yeah, let's do it in steps. So it's actually 4 plus the 7/5 is going to be 1 and 2/5 by itself, correct?
Yeah.
And then Max is exactly right. Stick the 4 and the 1 together and we get 5 and 2/5. Okay, the next one, we already have a common denominator, but we do have a problem. Can you take 4/5 away from 3/5?
No.
No, you don't have enough fifths to take that away. But we do have 3 whole whatevers, chocolate bars, pies, whatever here. So if I steal one of those and reduce it to 2 and break it up, I broke it into 5/5. I already had 8/5. I'm sorry, I already had 3/5, so I'm going to end up with 8/5. So 2 and 8/5 is kind of the improper, ugly mixed number version of 3 and 3/5. And now, look, I can subtract. Again, always start with the whole number. 2 minus 1 is?
1.
1, okay, and 8 minus 4 is 4/5, and I get 1 and 4/5, and that was called borrowing, okay. Another thing that can happen sometimes, okay, this time we're going to put everything together. We're going to have to get a common denominator. If I did rule of 4 on this one, 4 times 6 would be 24, but if I use common denominators, they both go into 12. That'll make it a little bit easier. There'll be less reducing at the end. So let's make them both something over 12, and I don't even have to really think about this part, do I?
No.
I wrote down the whole numbers, I put down the twelfths, now I got to think. Alright, so let's change colors. 4 went into 12 3 times, so the top will be
3.
1 times 3, which is 3. 6 goes into 12
Twice.
and so multiply 5 times 2,
10.
and I get 10. So I'm actually adding 7 and 3/12 plus 3 and 10/12, which is equal to 10 and 13/12.
Which is 11 and 1/12.
Which has to be reduced to 11 and 1/12, and that is called carrying. Okay, so this right here was borrowing, and this right here, what we did, is called carrying. And so that's a quick review. And the final one, again, we can do the same thing with the variables. Doesn't matter if it's a variable, it's the same variable, right? So right away, 3 plus 1, the whole numbers are going to be 4. The denominator is going to be x, whatever x happens to be. And the top is 2 plus 7, which is 9. And that may be top-heavy, but without knowing what x is, we don't know that, so we can't do anything. So we just leave it. That is final answer. Okay? Well, all right. So, folks, that's it. I want to thank Max for helping me out on the video. Nice recovery from not being here for a whole week. We're glad to have you back. And the rest of you, we will practice these skills in class tomorrow. Okay, thanks for watching.
Bye.
Bye.